we are constantly answering the same question from the media, which is, when are we going to bring dinosaurs back to life?
Because Jurassic Park.
Yeah. Well, right.
We're so simple. One great movie, and everybody's like, when's that going to happen?
And people actually say that my field was spawned by Jurassic Park. The whole idea that we could get DNA stuff, that's not true. It was actually the other way around. And Michael Crichton, when he wrote the book that became the movie, he credited a lab at Berkeley, Alan Wilson's group, the Extinct Species Study Group, which was the first group to show that you could get DNA in something after it died. That was actually from a quagga, which is a type of zebra. They had
what a
gotten,
cool name.
Yeah, right. Well,
Quagga.
in Dutch, in South Africa, they actually say the quagga.
Ooh, even better.
Yeah, it's better that way, but
Yeah.
it's kind of bad for the microphone, probably gross.
Quagga.
Yeah. I think it's the sound they're supposed to make, right?
Oh.
So they sound like I don't know. Who knows? Anyway, they showed that you could get DNA from this skin, and everybody was like, that is the coolest thing that I've heard in a long time. That must mean we can bring dinosaurs back to life. And everybody started racing to get the oldest and coolest DNA. And so there were papers in the best journals of science that never published anything that's wrong ever, that said, look, here's dinosaur DNA, and look, here's DNA from a Miocene-aged leaf, and look, here's this, and all of it is crap. We now know. In fact, the first dinosaur DNA sequences that were published, if you took them at the time and you typed them into the internet and you compared them to the earliest of what is today this big repository of all DNA sequences of everything that's ever been sequenced, what came back was a close match to a bird. We now know, because there's more DNA sequences there, that it was a chicken, an exact match to a chicken. And some investigative work found that the excavation team who'd been working on those bones had fried chicken for lunch every day.
So it's chicken contamination.
Yeah, it's like greasy fingers on your dinosaur fossils.
Oh
and
my
look,
God.
now we have ancient DNA.
That is hilarious.
So, yeah.
That's how little they knew about DNA. And what year was this around?
That would be the early 90s.
The early 90s. And when was DNA first discovered?
Well, the idea of DNA is much older than that, but it was really the idea. What really helped this field along was the invention of PCR. It's an acronym for polymerase chain reaction. It's a way of Kary Mullis, who discovered the idea of PCR while he was high on a road trip, right?
On LSD.
Yeah, that's right. Yeah, we should all do LSD, I think, because clearly you have your best ideas when you're high. Right?
Some people have great ideas. Some people go kooky. Some people lose their marbles and never come back.
Yeah, I think I probably would not have good ideas on LSD, but I'm willing to give it a shot.
Well, I like your scientific exploration mind.
A good scientist always wants to know.
You never know.
Yeah.
I mean, maybe there's a breakthrough waiting behind that little piece of paper.
Probably not. But
Probably not.
But you never know. Anyway, he discovered a way to photocopy DNA to make lots of copies of the same thing, which then made it possible to learn the sequence using the technologies of the day. And that was what made it possible, really, for ancient DNA to take off, was this ability to photo. Because when an animal dies or plant dies, the DNA in the cell starts to get chopped up into smaller and smaller pieces by things like UV, right? We go out in the sun, we put sunscreen on, and that stops the UV from breaking our DNA. But it's not terrible to get some sunlight, as you probably just saw. There was an article out saying, hey, dummies, we need some sunlight in order to make vitamin D. But we have a repair mechanism so that when your DNA breaks, it doesn't stay that way. We evolved this mechanism. But once you're dead, you no longer have the energy for that to work. And so these damaged parts of DNA accumulate. And also things like bacteria and microbes get in there and chew up the DNA to recycle the animal to the next generation or plant or whatever. And so the DNA that we get in an old thing, like a mammoth bone, is really short fragments, like maybe 30 or 40 or 50 letters of DNA long. In comparison, if I were to take a swab from my cheek and sequence that, I could get strings that are hundreds of millions of letters long. This is living DNA. So ancient DNA is in really crap condition. And it's also mixed with stuff. So if I extract DNA from a mammoth, I'll get some mammoth DNA, but I'll get a lot of those microbes that are in there chewing up DNA. I'll probably get some of my DNA because I touched that mammoth bone. I'll get DNA from whoever else touched that thing. This has been a real problem in archaeology because we're trying to get DNA from humans, but we're humans. And so we touch these things and then I don't know if it's my DNA or if that thing DNA. And
right.